Good morning, everyone. Have you ever really looked around and wondered about the science and engineering in everyday objects? Take your chair. It's a feat of structural design, not just a seat. Or the zipper on your jacket, hundreds of tiny teeth locking together with a simple pull. Even the Wi-Fi signal bringing you this video is a marvel of invisible radio waves. These things are so common, we forget they were once revolutionary inventions. Today, we're going to peel back the layers and reveal the elegant science behind the ordinary. Let's get started. Let's start with something you probably use today, maybe without even thinking about it, the zipper. Zippers are everywhere, on pants, jackets, backpacks, luggage, and even shoes. But have you ever wondered how this everyday object actually works? The secret lies in the slider, which is cleverly shaped like a Y. This simple piece is the heart of the zipper's magic. As you pull the slider, the angled teeth are guided together, hooking perfectly into place, one after another, almost like a tiny puzzle being solved in real time. The slider acts as a wedge, locking the teeth securely when you zip up, and prying them apart smoothly when you zip down. It's a tiny mechanism, but it does a big job. The real strength of a zipper comes from numbers, hundreds of tiny interlocking teeth working together to resist force and keep your belongings safe. It's a simple machine, but one that's been refined and improved for over a century. The zipper solves a surprisingly complex problem with mechanical elegance and reliability. So next time you zip up your jacket or bag, remember, it's not just a fastener. It's a marvel of precision engineering, designed to make your life easier, one zip at a time. The humble zipper is proof that the best solutions often hide in plain sight, quietly making our daily routine smoother and more convenient. That's the power of collective engineering. Brilliant minds working together to create something both simple and indispensable. Now let's move on to the next everyday marvel. Now let's head to the kitchen and talk about the microwave oven. You put in cold food, press a button, and it's hot. No fire, just microwaves. Inside, a magnetron generates high-frequency waves that bounce around, targeting water molecules in your food. These polar molecules spin and vibrate, creating friction and heat from the inside out. That's why watery foods heat up fast, while dry plates stay cool. It's not magic, just clever physics using water molecules as tiny heaters. The microwave, a perfect example of science making life easier. Let's talk about Wi-Fi, the invisible force connecting us right now. It's something we use every day, often without even thinking about how it works. Whether you're streaming music, video calling a friend, or just browsing the web, Wi-Fi is quietly making it all possible in the background. Your router is a two-way radio, turning digital data into radio waves on 2.4 or 5 GHz bands. These bands are like invisible highways, carrying information back and forth between your devices and the internet. 2.4 GHz travels farther and through walls, but it's crowded. That's why sometimes your connection slows down if too many people nearby are using the same frequency. 5 GHz is faster, but doesn't penetrate as well. It's perfect for high-speed activities like gaming or streaming, as long as you're close to the router. Data is split into packets, encoded onto radio waves, and sent to your device, which decodes them back into information. This process happens in the blink of an eye, so you barely notice any delay. When you send data, your device does the same in reverse. It's a seamless two-way street of communication, happening all around us. This invisible conversation happens millions of times a second, connecting people in homes, offices, and public spaces everywhere. It's a constant, high-speed exchange of information, all thanks to radio engineering. Without it, our digital lives would come to a standstill. Next time you stream a video, remember, it's not magic, it's science in the air. Invisible waves are working hard to keep you connected. Wi-Fi is the backbone of our connected world, linking cities, homes, and even outdoor spaces with seamless access to information. Let's see what nature has to teach us next, as we explore the wonders that keep us connected, both online and off. Now, an invention inspired by nature, Velcro. In 1941, Georges de Mestral noticed burrs sticking to his clothes and dog's fur. Under a microscope, he saw tiny hooks catching on loops, nature's fastener. He recreated this with 2 fabric strips, one with hooks, one with loops. Press them together, and thousands of tiny hooks latch onto loops, creating a strong, reusable bond. The strength comes from numbers. Many weak bonds add up to a powerful hold. Peel it apart, and you break one row at a time, making that iconic ripping sound. Velcro revolutionized everything from shoes to spacesuits. It's a perfect example of biomimicry, engineering inspired by nature's solutions. Sometimes the best ideas come from a walk in the woods. Let's talk about your refrigerator, not just how it keeps your food cold, but the fascinating way it actually moves heat from one place to another. A fridge is essentially a heat pump, cleverly pulling warmth from inside its insulated compartment and dumping that heat right into your kitchen air. It does this using a special fluid called a refrigerant. This refrigerant evaporates inside the fridge, absorbing heat from your groceries and everything else inside. The compressor, which acts like the heart of the system, squeezes this refrigerant gas, making it hot and high pressure so it can release the heat it's carrying. The hot refrigerant then travels through coils on the back of your fridge, where it releases the heat into your kitchen air. This is why those coils feel warm to the touch. As the refrigerant cools down, it condenses back into a liquid, ready to cycle back inside the fridge and start the process all over again, absorbing more heat. This continuous loop is what keeps your food cold, not by creating cold, but by constantly moving unwanted heat out of the fridge's interior. That's why, if you ever touch the back of your fridge, you'll notice it's warm. It's the heat your fridge has removed from inside. It's all about clever thermodynamics and energy transfer, not about generating cold air from nothing. The fridge is a silent, continuous mover of heat, working around the clock to keep your food fresh. Next, let's look at the magic in your pocket, your smartphone, and the science that keeps it cool. Let's talk about your smartphone touchscreen. It feels like magic, but it's all about electricity and precision. Beneath the glass is a grid of conductive material, creating an electrostatic field. Your finger, a conductor, disrupts this field, causing a voltage drop at that exact spot. The controller scans for these drops, pinpointing your touch instantly. That's how it tracks taps, swipes, and even multi-touch gestures. Gloves block the effect unless they're conductive. Water confuses the field. It's not magic, just brilliant electrical engineering at your fingertips. For light, we used to rely on inefficient bulbs that wasted energy as heat. Enter the LED, a tiny chip of semiconductor that turns electricity directly into light. Electrons and holes meet at the junction, releasing energy as photons, light. The color depends on the materials used. LEDs are efficient, long-lasting, and cool to the touch. White LEDs use a blue chip and a yellow phosphor to mix colors. This quantum leap in lighting has revolutionized how we see the world. Small chip, big impact. Let's end with the ballpoint pen, a marvel of microengineering. At its tip is a tiny ball bearing, bathed in thick ink. As you write, the ball rolls, picking up ink inside and transferring it smoothly to paper. The ball acts as both valve and distributor, preventing leaks and ensuring even flow. Precision is key. Too tight, it won't roll. Too loose, it leaks. Laszlo Biro's invention solved the messiness of fountain pens with this simple, elegant mechanism. It's gravity, friction, and perfect engineering in your hand. Everyday genius, right at your fingertips. So there you have it, hidden science in the objects all around us, quietly shaping our daily lives in ways we often overlook. From zippers to Wi-Fi, these inventions are the result of brilliant minds solving real problems, making life easier and more connected for everyone. They're reminders that the world is full of invisible marvels, powered by physics, chemistry, and engineering, all working together in harmony. Next time you use something simple, take a moment to appreciate the ingenuity and creativity behind it. Maybe understanding how things work will spark your own ideas and inspire you to create something new. The next everyday miracle could come from you. Imagination is the first step. Thanks for joining me. See you next time for more amazing discoveries.